So in this video, we are going to do the revision of matrices from Engineering Mathematics 1 by doing some MCQ questions. So let's start. So before doing anything, we must know some important points regarding the rank of a matrix. So see, only null matrix, or you may say zero matrix, have a rank 0. Okay. Otherwise, if you have any non-zero matrix, then rank will be either 1 or greater than 1. Okay, so 0 rank is possible only in the case of zero matrix, right? And the third point is if A is non-singular n cross n matrix. Like let's say you have some square matrix, okay, and that is non-singular. Non-singular means if determinant of that matrix is non-zero. Okay, you have a square matrix with non-zero determinant, then rank of that matrix will be equals to the order of matrix. Okay, it will be equals to order of that matrix, right? Similarly, if you have singular matrix, like let's say singular means, let's say you have any matrix of 3 cross 3, okay, and this is singular. Singular means if determinant of that matrix is 0, then rank will be less than 3, means rank will be less than the order of the matrix, okay. So next is if you have any identity matrix, okay, then its determinant will be 1. So rank of identity matrix is actually equals to the order. Fine. Fourth point is if you have any matrix of m cross n order, like let's say if you have a matrix of order 3 cross 4, let's say, then rank of this matrix will be minimum of 3 comma 4. So what is the minimum from 3 and 4? Obviously 3. So that means rank of this matrix can be either 3 or less than 3. It can be 2, it can be 1, or it will be 0 only if this is 0 matrix. Alright. And the fifth point says that if all the minors of order R are equal to 0, then rank of A will be less than R. Means if you are having all the minors of order, let's say 2, as 0, if you are getting the 0 value for all the minors of order 2, then rank cannot be 2. It will be either 1 or 0. And 0 is possible for 0 matrix or null matrix only. Fine. So all these points are actually coming from the minor method. Okay. But as you know that we are not much comfortable with that method. If they ask you the question regarding the rank, we will prefer echelon, row echelon form. Alright. So let's start with the questions and keep these points in your mind. So this is our first question. So they are asking what is the rank of this matrix. So very easy. So if they are asking the rank, so I'll just prefer just one thing, and that is row echelon form, right? So what is the row echelon form? So in order to convert this to row echelon form, I'm interchanging row number 3 with row number 1. Okay. So 2 1 3 1 4 0 2 6, and here we get 0 1 2 minus 2, right? Now what is next? Further, I want all the element under this to be 0. This is already 0. Convert this element to 0. So how we'll do that? So apply R2 minus 2R1, because already this 4 is the multiple of 2. So this is easy for us to convert this 4 to 0 element. So this is 0. Okay, 0 minus 2, that will be minus 2, right? And 2 minus 2 into 3, that will be 2 minus 6 minus 4. And then we have 6. 6 minus 2 into 1. So 6 minus 2 is 4, right? And here we have 0, 1, 2 minus 2, right? Now what is the second row, first non-zero element? This one. Under this I want this element to be 0. Okay, so just convert it to 0 element by operating R3 minus plus 1 by 2 R2. So what will you get? So you'll get 2 1 3 1 0 minus 2 minus 4 minus 4, and this row will be completely 0. So how many non-zero rows are there? 1 and 2. Non-zero means having at least one element 0. So there is only one 0 row. Other two rows are non-zero rows. These are non-zero rows. So rank is 2. So B option is correct. Now let's move to the next question. So here they are asking about the normal form of this matrix. Now see, though they are asking you the normal form, but I am not going to solve this. I am not going to convert the question into normal form. Reason being, I'm just concerned with the rank. And for rank, I prefer only row echelon method because obviously that saves my time. Okay. So what we'll do, we'll just calculate the rank by using row echelon form. So what we'll do, first of all, I'm operating this thing. I'm interchanging row 2 with row 1. So what we'll get? So we'll get this thing, right? Now convert these three elements to 0. So what we'll do? R2 minus 2R1, right? R3 minus 3R1, R4 minus 6R1. So what we'll get? So we'll get 1 minus 2 minus 4. Here you'll get 0. 3 plus 2, that will be 5, right? And then minus 1 minus 2 into minus 2. So that will be plus 4. So here you'll get 3. Okay. And minus 1 and minus 2 into minus 4. So this will be minus 1 plus 8. So this will be, so minus 1 minus 2 into 4, and that is 7, right? So next is third row. So third row, here you'll get 0. Fine. And further this 1 minus 3 into this. So plus 3. So this will be 4, right? And here you'll get 3 minus 2 into minus 3, 6 plus 6. So this will be 9. Here minus 2 and minus 3 into minus 4, 12. So this will be 10. Okay. Similarly, here you'll get 0, 3 and plus 6. This will be 9. 0 minus 6 into minus 2. This will be 12. Okay. And minus 7 into 20 plus 24. That will be plus 24, like here we are multiplying with minus 6, so plus 24, that will be 70. Now you can observe one thing, we can operate one operation, and that is you can do this thing, R4 minus R2 minus R3, like you may do this thing, like you can observe 5 plus 4 is 9, this is actually fourth row is the sum of these two rows, right? So by doing things, what will you get? So by operating this, we are getting this thing, right? And here, now next is like I want 0 here. So what you can do, R3. So here I am operating 5 R3 minus 4 R2. So see 1 minus 1 minus 2 minus 4, 0, 5, 3, 7, 0, 0. And here 5 into 9 minus 4 into 3. So what you will get? 45 minus 12. So that will be 33. And last row is 0. Do I need to calculate this thing? No, because see, I want the, a number of non-zero rows. So we get at least one element here that is non-zero. So we get one non-zero element. So that means rank will be 3. So rank of this matrix will be 3. I don't need to calculate this element. So just save your time, because there are so many questions when we used to do the MCQs questions. Okay. So just do the things which are required. Like here I got the idea that okay, rank is 3. Okay. Now see, from here how we'll get the idea about the normal form. So rank is 3 and the given matrix is of order 4 cross 4. Okay. So if your rank is 3, like that means you are getting identity of order 3. Okay. And other things remains 0. So that means if you partition this matrix, you will get this form, B. Okay. So B is the correct option. Okay. We are not getting I4. We are not getting identity of the order 4. Okay. Rank cannot be 2. It can be this, but again, because rank is 3 and here they have given I30. I30 means your matrix is having the order 3 cross 4, but that is not true. We are having 4 cross 4 matrix. So if you are taking this one, this is very much clear that this option is wrong. You don't need to check anything because I30 is not possible for this. Otherwise, you'll get the matrix of order 3 cross 4. But our matrix is of order 4 cross 4. So you can directly cancel this out. Okay. And rank is 3, and out of these 3 options, obviously in second option we are having I3. So this is the correct option. So you don't need to solve for the normal form. Just go with the echelon form, row echelon form. Okay, because that is that takes less time, right? Now let's move to the next question. Now in this question, first of all, see what they have given. They are asking you the value of x for which you will get rank of this matrix less than or equal to 2. Now first approach is, if you are not aware of any of the thing like minor method or the important points, then you can just substitute the value 2 by 3 here and you can check what is the rank. Okay, similarly after that you can check 11 by 3 and then again you can check whether you are getting the rank 2 or less than 2. Okay, but second approach is like, because order of this matrix is 3 cross 3, but they are saying rank is less than equals to 2. That means this matrix is singular, because if rank is equal to the order, then that is non-singular, and otherwise this is singular. So determinant of A will be 0. Now just calculate the determinant and equate it to 0. So what I'm going to do, I'm going to use some operations. So what first thing what I'm going to do, I'm going to do R1 plus R2 plus R3. Okay, and changes will occur in row number 1. So this will give you 3x minus minus 8 plus 6, this will be minus 2, 3 here again you'll get 3x minus 2, 3x minus 2, and other rows remain same. Fine. Now can you take this 3x minus 2 common? So just take 3x minus 2 common from this determinant. See, this is the difference between the matrix and determinant. In case of determinant, you can take something common from the single row or single column. But in case of matrix, if you are taking something common, that should be common from each and every element of the matrix. Right? Now this is what we get. Now next is, see what you need to do, apply column operation. So column 2 minus column 1, column 3 minus column 1. Okay, I'm just simplifying this in order to find the determinant. Now see here 3x minus 2 as such, and after applying these operations we'll get this thing. Now this is simple to expand this thing because this is the triangular matrix. Now find the determinant. Determinant will be product of diagonal elements, right? This will be 1 into 3x minus 11 square, and because this is singular it should be 0, determinant should be 0. So from this what you are getting, x is equals to 2 by 3 and 11 by 3 both. Okay, in fact 11 by 3 is coming 2 times. Fine, so that means C option is correct. We are getting the value of x as 2 by 3 and 11 by 3 both. Fine. Now next we'll do some questions based on the consistency of linear equations. For that you must remember some important results. Okay, so what are the results? The first thing is, if you have non-homogeneous linear equation, that is Ax equals to B type of equation, you need to find augmented matrix first, and we are denoting this thing as C. Okay, then just check the rank of A and the rank of augmented matrix. If these two things are not equal, then there is no solution, means the system is not consistent, or you may say inconsistent. For example, if I say x plus y is equals to 2, x plus y is equals to 5. So obviously this is not possible. Such kind of things are inconsistent. So if rank of A and rank of augmented matrix, C is augmented matrix, is not equal, then there is no solution. So we will not calculate further anything. Okay. Next is, if rank is equal, if rank of augmented matrix and rank of A is equal, then Next task is to check how many solutions you have. Either you are having only one solution or infinite solution. For that, we will further check that whether the rank of A and rank of augmented matrix is equal to the number of unknowns or less than number of unknowns. If this is less than number of unknowns, then there will be infinite number of solutions. If this is equal to number of unknowns, then there will be unique solution. See, this is the very important thing which you have to keep in your mind. Okay, so let's do some question based on this. So this is the very important question. So they are asking you the lambda mu for which these equation will have, the first part is no solution, second part they are asking unique solution, more than one solution, right? So first of all, what is the augmented matrix? I'm going to write augmented matrix here. So 1 1 1. I hope you have done this thing. So before, I hope you know how we used to write the augmented matrix. So 3 10. Okay, then 1 2 lambda and me. This is my augmented matrix, right? Now convert it to row echelon form. So what I'm going to do, I'm going to operate this thing R2 minus R1 and then R3 minus R1. So what you'll get? We'll get 1 1 1 6, 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, 10 minus 6 4, 0, 2 minus 1 1, lambda minus 1, okay, and then we'll get mu minus 6. Fine. Now here I want this element to be 0, so what should I operate? So I'm going to operate R3 minus R2. So what we'll get? We'll get 1 1 1 and 6 as such, 0 1 2 4, and here 0 0, lambda minus 3, mu minus 10. Okay ji. Now see, we will check from the given conditions. So here they are saying if lambda is not equals to 3, mu is 10. So just check if here you have a non-zero element. Let's say you have non-zero element means this. Okay, 4. Let's say here you have some non-zero element. Let's say that element is 5 and mu is equals to 10. Mu is equals to 10 means this thing is 0. So what will be the rank of augmented matrix? Rank of augmented matrix will be 3. Rank of A means this thing. Rank of A will be 3. So that means this will be consistent. And what is the number of unknowns? That is 3, x, y and z. So rank of augmented matrix, rank of A and number of unknowns will be same. Okay, so that means this first option is corresponding to what? This is corresponding to unique solution. So I'm writing U here. Okay. Now let's check the second possibility, second option. Now second option is saying if lambda is equals to 3 and mu is not equals to 10, means this thing is 0 but this thing is non-zero. Obviously if mu is not equals to 10, let's say this is 11, then 11 minus 10 will be 1. So if this thing is, this thing is 0 but this is, let's say here you have some non-zero element 1. Then what will be the rank of augmented matrix? Rank of augmented matrix will be equals to 3. But what is the rank of A? A means only this matrix. How many non-zero rows are there? So 2. So a rank of augmented matrix is not equals to rank of A. So that means this is the case of no solution. So I have written N here. Okay. Now let's move to the third option. So I'm doing the question by using the options. Okay. And this type of question is very important. Fine. The third option is saying mu and lambda is not equals to 3 and mu is not equals to 10. So let's say lambda not equals to 3. Let's say this is 4. Let's say lambda is 4 and mu is 11. So what will you get? So this will be 0, 1, 2, 4 and 0, 0. If this is 4, this will be 1, this will be 1. So what is the rank of this augmented matrix? 3. Okay. Rank of augmented matrix will be 3. And what is the rank of A? If you consider this thing, this is again 3. Rank of A is also 3. And number of unknowns. Number of unknowns are also 3. So this is the case of unique solution. Means from this case also you are getting unique solution. So I am writing U here. Fine. Now come to the option number D. Now in option number D, they are saying lambda 3 mu 10, means if this thing is 3 and this thing is 10, so obviously both the things will be 0, so you'll get 1 1 1 6, okay, 0 1 2 4 0 0 0 0, okay. So what is the rank of augmented matrix? Rank of augmented matrix and rank of A both are equal to 2, but this is less than number of unknowns because unknowns are 3, so that means this is the case of infinite solution. So here you'll get infinite solution. All right. Now fifth is saying lambda is equals to 3 and mu can have any value. Okay. So we'll check this thing. Now see what they are asking. What is the first part? Come to the question now. First part is when you will have no solution. So obviously we are already done with this. So from B option we are getting no solution. So for first part B option is correct. Okay, so for first part B option is correct. Second we'll do later. First of all we'll do third one. So more than one solution means infinite solution. Okay, and when we are getting infinite solution, only in one case, this one. Okay, so that means D option is correct for third part, for this part. Alright, now come to the second part. Second part is asking about the unique solution. So when you are getting unique solution, in case of A and actually C also, both are giving you the unique solution. So that means here see, lambda is not equals to 3 in both the cases, but here we are taking mu is equals to 10, here we are getting mu not equals to 10. That means mu is not playing any role here. Okay, so lambda should not be 3, but mu can have any value for unique solution. So that means option E is correct. Option E is correct for unique solution. Okay, fine. So this is the solution of this question. Now let's move to the next one. See class, you have to use this approach, okay, and you have to remember all the conditions. Only then you will be able to solve the question, because they are not going to ask you what is the solution, like what is the value of x, y and z, because otherwise that question you can solve by just substituting the values in x, y and z. Okay, so they'll ask you like is it consistent, is it having no solution or infinite solution or unique solution. Now here see what is the given equation. This is the given equation. Okay, now find the augmented matrix. Augmented matrix is this. Okay, now find the rank. What is the rank of this matrix? So I'm just multiplying this with 3 and this with 2. Okay, so R2 2R2 minus 3R1 I'm operating. So you'll get 4 6 5, here you'll get 0, again 0, and 2 into 7 14 minus 3 into 5 15, 14 minus 15 minus 1. Okay, so what is the rank of this thing? Rank of augmented matrix is 3. And what is the rank of A? Rank of A is 1. Right? So that means, sorry, not 3, it is 2. So if both the ranks are not equal, that means there is no solution. So because rank of A is not equals to rank of augmented matrix, so there is no solution. Fine. Let's move to the next question. So see, next we'll do some question on the basis of homogeneous equations. So homogeneous equations are always consistent because there is one trivial solution, that is trivial means that always exists. Okay, that is zero solution. Zero solution means because in case of homogeneous solution, on the other side we have zero matrix, so you can assign all variables as 0. You can assign 0 value to all variables, right? And that is the solution which is called as trivial solution. So in case of homogeneous solution, you may have, sorry, homogeneous linear equation, you may have infinite solution or unique solution. Okay, so what are the conditions? So it always have a solution. Find rank. If rank is equal to number of unknowns, if this is equals to number of unknowns, okay, like you can see here on this side, then you will have unique or trivial solution. Unique means only one, and one solution we already know, zero solution. But if rank is less than number of unknowns, then you will have non-trivial solution. Non-trivial means infinite number of solution. Okay, these are some points. So now let's do some questions. So first is this, that find the value of B such that system of equation has trivial solution. Trivial solution means Trivial solution means rank of A should be equal to number of unknowns, right? How many unknowns are there? 3. So that means the rank of A should be 3. Okay. So, or like if I'm saying like what is the A? A matrix is 2 1 4 1 1 3 2 3 B, right? So just operate R2 interchange with R1. Okay, so what we'll get? 1 1 3 2 1 2 4 3 B. Now I'm operating R2 minus 2R1. Actually I'm converting this to row echelon form. Okay, because whenever we need rank we'll convert it to which form? Row echelon. So 1 1 3 0 and 1 minus 2, that will be minus 1, 2 minus 6 minus 4, right? Now here 4 minus 1, 4 minus 4, sorry, 0, 3 minus 4 minus 1, and here you'll get b minus 12, right? Now further we'll operate R3 plus, sorry, minus R2, okay, because we need row echelon form. Now if you operate this, what will you get? So 1 1 3 as such, 0 minus 1 minus 4, 0 minus 1, this will be 0, okay, and b minus 12 and plus 4, so this will be b minus 8, right? Correct. Now here, see, this is my row echelon form. So they are asking you to have a trivial solution, and trivial solution exists only if rank is equal to number of unknowns. Means I need rank 3. Now if b minus 8 is 0, then rank will be 2, which is not acceptable for this case. Okay, which is not acceptable. So that means b minus 8 should not be 0. So that means b should not be 8. So D option is the correct option. Fine. Now let's move to the next question. Now next question is just related with the this matrix type. So they are asking you what type of matrix is this. Okay, so see, symmetric you already know. If A transpose is equals to A, then it is symmetric. Okay, Hermitian means if you take the conjugate and then you take the transpose, and suppose your matrix come out as the same matrix, then this is called Hermitian matrix. Okay, and if it is come out as minus of A, then it is called skew Hermitian. So let's check what is the conjugate of this. Conjugate means whatever the elements you have, take the conjugate of this. So conjugate of real numbers is same, so these elements will be same. What is the conjugate of 3 plus 4 iota? 3 minus 4 iota, and here you'll get 3 plus 4 iota. Now take the transpose. So what you'll get? 2, 3 minus 4 iota, 3 plus 4 iota, and 2. And what is this? This is A. So that means A conjugate transpose come out as the same matrix. So this is Hermitian matrix. Okay. Now is it symmetric? Is it symmetric? You can check. So what is the transpose of this? If you take direct transpose, what is the transpose of this? Transpose is 2, 3 plus 4 iota, 3 minus 4 iota, and 2. Is it symmetric? No, this is not same as A. This is not A. Okay, so this is not symmetric. So that means B is the correct option. Fine. Now let's move to the next topic. So next topic is dependence and independence of uh, vectors. Okay, so what is the short trick? Short tricks is they'll provide you some vectors, like they'll provide you some vectors v1, v2, v3. Let's say v1 is 1 2 3, okay, 4, and v2 is a b c d, and v3 is, let's say, k j m n. Okay, what do you need to do? Just generate one matrix. Generate one matrix from this. Okay, by using these vectors, generate a matrix. And then there are two approaches which you can use. See, if your generated matrix, let's say A, let's say this matrix is A. If A is square matrix, if this is square matrix, then you just check one thing. If determinant is 0, then linearly dependent. If determinant is non-zero, then this will be linearly independent set of vectors. This is possible if you are having square matrix. If you have rectangular matrix, in case of rectangular matrix, you can use rank. So rank, if rank is equals to number of vectors, okay, number of vectors, let me write it here, then linearly independent. Okay, if rank is less than number of vectors, then this will be linearly, yes, this will be linearly dependent. Okay, this will be linearly dependent. Fine. This approach you can, this rank approach you can use in both the cases, like in square case also you can use this. But I suggest that if you are having square matrix, then use this determinant approach. Okay, that like if your rank is equal to number of vectors, then linear independent. If this is less than, then linearly dependent. Okay, and if determinant is 0, linearly dependent. If determinant is not equal to 0, then linearly independent. So let's do some questions. So here they are asking you the value of k, so that this is linearly dependent. So first of all, we'll generate one matrix from this. So what you'll get, 1 1 0, 1 2 minus 1, and 2 k minus 1. Okay, now see, they are asking you linearly dependent vectors. They want linearly dependent set. So this is 3 cross 3 matrix, which is square matrix. Now linearly dependent means determinant of this matrix should be 0. So find the determinant. What is the determinant? 1 minus 2 plus k, okay, and minus 1, and then you'll have minus 1 into minus 1, minus 1, and plus 2, right? And this should be equal to 0. So this will be minus 2 plus k, and here you'll get minus 1 equal to 0. From this you'll get k minus 3 equal to 0. So k is 3, right? That means C option is the correct option. Fine. Now this is the next question based on the same topic. So here what they are asking, again they have given the vectors and they are asking whether this is linearly dependent or independent. So just generate the matrix and do some smart work. Take the vector like on the first position, which is having 1 here. First element is 1. So you can take any of these. I'm taking 1 3 1, 1 2 2, 2 2 1. Because rank of A and A transpose is same, so it hardly matters. So I'm operating to find the rank. See, you can just check one thing. This is square matrix. You can check one thing. If determinant is 0, linearly dependent. If determinant is non-zero, linearly independent. Okay, or you can use the rank approach also. But see, whenever they'll give you some option that both, this is absolutely wrong, because any system cannot be linearly independent and dependent at the same time. Okay, similarly none of these will be wrong, because obviously if you have some system of vectors, that will be either linear independent or linearly dependent. If both the options are there, that means answer will be in either linear independent or linearly dependent. Okay, so let's find the rank. So 2 minus 4 minus 1, and then what we'll have, 3 minus 2, correct, plus 2, and then you'll get what, 3 to the 6 and minus 2. See, I'm just concerned with that whether this answer is non-zero or 0. Okay, so this is minus 2 and minus 1, and 6 minus 2 is 4, 4 into 2 is 8. So this is, I think, coming out as 5, which is not equals to 0. So that means this is linearly independent. Okay, because rank is come out as not rank, determinant is come out as non-zero. So this is linearly independent. Fine. So A option is correct. Now see, sometimes they give you such type of questions where A, B, C are given as matrices, and they are asking you whether this is forming a linear dependent set or linear independent or both or none. So as I told you in the last question also, these two options are Wrong. Okay. Every time whenever they ask you linearly dependent, independent, definitely they'll give you these two options because they have to give four options. Okay. So you can directly cancel this. Now how you will calculate this? From the first matrix, like you can prepare this thing. Like this is first element of first matrix is representing the first row. Okay. So I'm generating the new matrix, let's say P. So next matrix is 1, 1, minus 3, minus 2, 0 and 5. Next is 4, minus 1, 2, 1, minus 2 and minus 3. Now I'm just concerned with the, the thing that whether this matrix is having rank 1, no, 2 or sorry 3. Like how many vectors we have? 1, 2, 3. So we just want to check whether the rank of this matrix is 3 or less than 3, because obviously this is not square matrix, so we cannot use the method of determinant, because determinant is possible only in case of square matrix. So we have to go with the rank method. So first of all I am interchanging this to this form, row echelon form, by using this row operation. So after operating this, what will we get? This thing. Now next is just operate operations R3 minus 4 R1 and R2 minus 2 R1. Fine. So what we'll get? This is what we'll get after operating these two operations. Now operate R3 minus R2. So what we'll get by operating this thing? So see, so we will get 1, 1 minus 3 minus 2, 0, 5 as such, 0 minus 5, 5, second row means as such. Okay, here 0, 0 and here 14 minus 5, that will be 9. Now see, do I need to calculate these things? No, because this is 0 or non-zero hardly matters, because this is row echelon form. We are getting the number of zeros in increasing order, right? So see, what is the rank? Rank is come out as 3, because there will be 3 non-zero row, because if at least one element come out as non-zero in some row, that row will be considered as non-zero rows in that case, right? So here we get this 9 as non-zero. So 1, 2 and 3, there are 3 rows which are non-zero, so rank is 3. So because rank is 3 and this is equal to number of vectors, because how many vectors are given here? So this is first vector, second, third. So that means this is linearly independent. So you don't need to do anything. So B is the correct option. Fine. Now let's move to the next one. So this is the very important topic which we are going to do, eigenvalues. Okay. So first of all, just keep in mind that in case of square matrix, we use to calculate eigenvalues and eigenvectors, and eigenvalues of A and its transpose will be same. Okay. Second thing is the sum of the elements of principal diagonal of a matrix is called trace. Okay. And sum of the eigenvalues and trace is same, like sum of the diagonal element of the matrix A and sum of the eigenvalues is equal. Okay. Similarly, product of eigenvalues is actually equals to the determinant of A. This is very important. Now, if lambda 1, lambda 2, lambda n are eigenvalues of A, then k into A, where k is some non-zero constant, then this matrix will have eigenvalues this. You just need to multiply each eigenvalue with k. Okay. Second thing is, if they are asking you A power m, what is the eigenvalue of A power m? A power m will have the eigenvalue, like you have to take the power m for all the eigenvalues of these eigenvalues. Okay, so whatever the eigenvalues you have for A, okay, you just need to take the power of those eigenvalues as m, okay, in order to get the eigenvalues of A power m. Similarly, if all the eigenvalues are non-zero and their A inverse exists, then what will be the eigenvalues of A inverse? That will be reciprocal of the eigenvalues of A. Fine. Similarly, if lambda is the eigenvalue of a non-singular matrix, then adjoint, because adjoint we can calculate only if you are having the non-singular matrix. Okay. So if you are having non-singular matrix A and eigenvalues is lambda, then its adjoint will have eigenvalue determinant of A over lambda. these are some points which you should keep in your mind. Now let's start. So here see, they are saying that there is a matrix of 3 cross 3. Determinant is 4. Determinant of this matrix is 4, and eigenvalues, two eigenvalues are given as -1 and 2. We know that product of eigenvalues is equals to determinant. So this is 4 is actually equals to product of eigenvalues, right? Now let's say the third eigenvalue which they are asking in this question, let's say that is p. So that means -1 into 2 into p should be equals to 4. So that means p will be equals to 4 over -2. So that means third eigenvalue is -2 after cancelling this thing. So A is the correct option. Fine. So by using the property, we have done this question. Now next question is, an eigenvalue of a square matrix A is lambda is equals to 0. Then now see, if you have 0 as an eigenvalue, okay, that means if at least one eigenvalue is 0, obviously determinant will be 0, because determinant is product of the eigenvalues. Okay, so if determinant is 0, what you can conclude? Obviously, if determinant of some matrix is 0, we call it singular matrix. Okay, singular matrix. So C is the correct option. Okay, so first option is wrong. This is not necessary that you'll have symmetric matrix every time if you're having 0 eigenvalue. Similarly, skew symmetric, this is also not necessary every time. E option is also not correct. F is also not correct, because it's not necessary that you'll have even order matrix or odd order matrix. Fine. So C is the correct option. Now let's move to the next question. Now here they have given you A matrix as this, which is a triangular matrix. And as I told you in the previous video, where I have covered the topic of eigenvalues, because this is a very important topic. So I told you that in case of triangular matrix, eigenvalues are actually equals to the diagonal element. So what is the eigenvalues of A? Eigenvalues of A are -1, -3 and 2. So what will be the eigenvalues of A square? So as I told you, that A power m used to have the eigenvalues as lambda power m, lambda 2 power m, lambda 3 power m, right? So here this m is 2. So what will be the eigenvalue of A square? So A square will have eigenvalues -1 square, -3 square and 2 square. That is 1, 9 and 4. So B is the correct option. Fine. Now let's move to the next one. So here in this question they are saying that we are having one square matrix A, okay, and eigenvalue of this matrix is lambda, and they are asking that what will be the eigenvalue of K into A transpose, right, where K is some non-zero scalar. So as I told you that if A is having eigenvalues lambda, okay, if A is having eigenvalue lambda, then K into A will have eigenvalue lambda into K, right? And eigenvalues of A and A transpose is same. Like if you're having any eigenvalue lambda for some matrix, then same eigenvalues you will have for the transpose also. So if Ka matrix has eigenvalue K lambda, then what is the eigenvalue of Ka transpose? Obviously it will be same, right? So option C is correct. Okay, so these properties are very much important. Fine, let's move to the next one. Now next question is regarding the eigenvalues of this thing. So we'll use Cayley-Hamilton theorem here. So what is Cayley-Hamilton theorem? Cayley-Hamilton theorem states that every square matrix satisfies its characteristic equation, right? Now here just find the characteristic equation, which is very easy because this is upper triangular matrix. So lambda cube minus sum of the diagonal elements. What is the sum of the diagonal elements? That is 0, lambda square plus sum of the minors of the diagonal elements. Okay, so that will come out as -7. You can just check this thing. Okay, and determinant, because this is upper triangular matrix, so that will be product of the diagonal elements, and that is coming out as as 3 into minus 2 into this, that is coming out as 6. Okay, this is our characteristic equation. Now see, this formula I have already explained in the previous video. If you are not aware of that, then I'll put this link in the description box. You can watch that recording video, because that is very important, you know, to know this thing. This is very important topic. Alright, so you must know the shortcuts and short tricks which are required. So this is lambda cube minus 7 lambda and minus 6 equals to 0. Now see here, as this Cayley-Hamilton theorem states that every square matrix satisfies its characteristic equation. So that means this thing will be equals to 0. Now I'm going to use this thing in order to find this one. Okay, so here we are having a cube plus 5a plus 8 identity. Can I write this thing as a cube minus 7a minus 6 identity? Here c plus 12a, right, and plus 14 identity. Can I write this thing? Obviously, right? So this is actually 0 by using this Cayley-Hamilton theorem. So that means this expression is actually come out as this. Okay, 12a plus 14 identity. Now because A is this triangular matrix, then obviously 12 into A will be triangular matrix and 4 into identity is also triangular matrix. And in case of triangular matrix, what is the eigenvalue? Eigenvalues are only diagonal elements. So in order to save the time, I'm not going to calculate the complete 12 into A. So I'm just calculating the diagonal elements. Okay, so this will be minus 12, and then 12 into 3 36, and 12 into 2 minus 24, and here you'll get 14 14 14. Now if you add these two matrices, what will be the diagonal elements? Because diagonal elements, this is the upper triangular matrix, and diagonal elements will be the eigenvalues. Okay, so we don't need to calculate the other components and the other elements. Okay, just leave it as such. So minus 12 plus 14 and 36 plus 14 and minus 24 plus 14. So that means this is giving you what? This is giving you this is 2, 50 and minus 10. So these are the eigenvalues of this thing. So that means C option is correct. Okay. Now the last question here, they are asking you the eigenvalues, but they are asking you whether the eigenvalues are real and distinct, or real and repeated, or complex, or purely imaginary. So in order to get this thing, we have to find the eigenvalues. So what is the formula for calculating the characteristic equation? Because first of all, we have to find the characteristic equation. Now see, this is the formula to find the characteristic equation, right? So here lambda cube as such, what is the trace? Trace is sum of the diagonal elements of A. So that is 2. So 2 lambda square plus sum of the minors of A. What are the minors here? So what is the minor of diagonal elements of A? Sorry, diagonal elements of A, right? So what is the first diagonal element? 2. What is the minor of this? Find the determinant of this. So minus 1, and this will be give you minus 3. So first is minus 4, I'm writing here. Second diagonal element is 1. So leave this column and this row. So 2 into minus 1, minus 2, and minus 3. That will be minus 5. And next is minus 1, so leave this column and this row. So 2 minus plus 2. So this will be 4, right? 2 and that will be plus 2. So that will be 4. This will be cancelled. Sum of this will be minus 5. So this is minus 5 lambda. And what is the determinant? Determinant you can easily calculate. Okay. So determinant is actually minus 6. Okay. This is minus 6 equal to 0. So lambda cube minus 2 lambda square minus 5 lambda plus 6 equal to 0. Now first root we have to calculate by hit and trial method, okay, which you already know. So we start with the 1. Now fortunately 1 is satisfying this, right? Like 2 and 5, minus 7, and this is also 7. So 1 is satisfying. So 1 is the first eigenvalue. Okay, first eigenvalue. Now how we'll calculate the other two values, other two eigenvalues, because obviously this is 3 cross 3 matrix and we'll have 3 eigenvalues. So we have to find the other also, because we have to check whether the eigenvalues are distinct or repeated. Okay, so I told you the formula, lambda square minus trace of A, means sum of the diagonal elements of A minus first eigenvalue. Okay, this is the coefficient of lambda. This is the coefficient of lambda I am writing here, and plus determinant of A over first eigenvalue. First eigenvalue. Okay, equal to 0. So lambda square, what is the trace? Trace was 2. So 2 minus 1 lambda, and determinant was minus 6 over 1 equal to 0. So what we'll get? So we will get lambda square minus lambda and minus 6 equals to 0. So what, this is quadratic, and you can easily solve this. So this is lambda square and plus 3 minus 3 lambda plus 2 lambda minus 6 equals to 0. So if you factorize, you will get lambda minus 3 lambda plus 2 equal to 0. So what are the roots? Minus 2 and 3. And what was the first eigenvalue? That was 1. So these three values are distinct and real. That means option A is the correct option. Fine. So see, because we are having MCQ question, and in case of MCQ exam, we used to have large number of questions, right? So questions are more, so we have to save our time. All right, and these are some things, some points which you should keep in your mind while doing the questions. So thank you very much. This was all about this matrices from my side. Thank you very much for your cooperation, and I'll see you in the next session.